Hello students, today I am going to cover 7th, 8th and 9th lesson because most of the part from functions we have already completed. Okay, then what I have decided that I will go fast and at the end I will do more of the past paper questions. Okay, I will solve at least 3 papers, okay, before your exam, so that you get an idea. Full papers will be there. Okay then. So in this lesson I am going to cover everything from the functions, rest of all the functions, composite function, inverse function, then composite of inverse and the given function. So f dot f inverse is same as f inverse dot f of x, which is equal to x, right? Then the solution of quadratic equation, you know it is a simple topic, so I will skip that. Discriminant delta, you already know about delta b square minus 4ac, right? Then exponential function a raised to x and e raised to x, a raised to x, e raised to x, you know about it. So which one will be giving you growth and which one will be giving you decay, that also I will discuss. Then transformations, this is important part, transformation. I am going to solve past paper question on transformation so that you understand it well. Then solving equations both graphically and analytically, using technology to solve the variety of equations including those where there is no appropriate analytical approach. Yeah. Polynomial function, their graph and equation, zero, roots and factors. You all know about it. Okay then. So reciprocal function, you know that reciprocal means when you invert anything upside down, numerator becomes denominator, denominator becomes numerator, that is called reciprocal. And in the same way we have the reciprocal function y is equal to k over x, or f of x is equal to 1 over x, like that. Now whenever there is x in the denominator, you have to be very careful because x cannot be 0. I mean the denominator cannot be 0. If it is single x, then x should not be equal to 0, that will be its necessary domain. Okay, but if there is something like 1 upon x minus a, then x should not be equal to a, because if x is equal to a, the whole denominator will be 0 and it will no more be a real function, right? 1 upon 0 will not be defined, it will be infinite. Okay, and then another thing about reciprocal function is there will always be vertical asymptote as well as the horizontal asymptote. Okay, so for example in this function y is equal to 1 upon x, the domain is set of real numbers such that x is not equal to 0, and it will have two asymptotes. As I said, every reciprocal function will have at least two asymptotes, maybe there are more. So the first asymptote will be x is equal to 0, the vertical asymptote, and the second asymptote will be y is equal to 0, means the y axis and the x axis will be the asymptotes. Okay, y is equal to 0, x is equal to 0, and whenever there are asymptotes, the curve will be between the asymptotes. Okay, so what I mean is it will be here and here because the two asymptotes are here and here, right? Then one more thing you should remember, if the reciprocal function has negative x, okay, then the graph will be in the second and fourth quadrant, like this. Whenever it is 1 upon minus x or minus 1 upon x, then the graph will be in the second quadrant and the fourth quadrant. But here in this case 1 upon x is positive, so whenever positive, the graph will be in the first and the third asymptote. So I hope you will remember it. This is true for every type of odd function. Okay, whenever the highest power is odd, the function will have graph in first and third quadrant if the highest power is positive. Okay, positive. And if highest power is negative, its graph will be in the second and the fourth quadrant if the highest power is negative. whether it is in the numerator or the denominator, right? Okay. Then you can decide the vertical and the horizontal asymptote by taking limit values also, right? So look here, because in this function x cannot be equal to 0. So what if x is to the left of 0 and x is to the right of 0? So that time we will check it. So x tends to 0 minus means to the left of 0. 1 upon x will tend to negative infinity, because when x is to the left of 0, when the values of x are to the left of 0 means here, okay. So here how is your graph? 1 upon x is negative infinity, means it is below the x axis, it is going towards negative infinity, okay. It is tending to negative infinity. And when you take the right side part of 0, when x is to the right of 0, x tends to 0 plus means to this side, okay, then your 1 upon x will tend to positive infinity, means your graph will go up and up towards positive infinity, though it will never be infinity, but it will go towards positive infinity. So that decides your asymptote. So therefore the vertical asymptote will be x is equal to 0. That will decide your vertical asymptote. Now for horizontal asymptote, y is equal to 0. When you take x tends to infinity, because for the horizontal asymptote you have to check what happens when x tends to infinity and x tends to negative infinity, okay. So 1 upon x, the whole function tends to 0 plus, means it is to the right of 0, x is equal to 0, right? I mean y is equal to 0. To the right of y is equal to 0 means above the x axis, okay. Because the whole function means 1 upon x, 1 upon x tends to 0 plus, it means it is on the above, it is above the x axis, on the positive side of y is equal to 0. So positive side of y is equal to 0 is above the x axis, negative side will be below the x axis. So when x tends to negative infinity, 1 upon x will tend to 0 minus, means it will be towards the negative side of y 0, okay, below the x axis, right? And therefore this will decide your horizontal asymptote, y is equal to 0, okay. And if you have any function like this, y is equal to k upon x, then the graph will pass through 1 comma k, k comma 1, minus 1 comma minus k, and minus k comma minus 1, okay. So whatever is your value of k, it is going to pass through these points, okay. So you should remember this thing. Then quadratic equation, you already have studied quadratic equation in your MYP and lower classes. Ax square plus bx plus c is equal to 0 is a quadratic equation. Definitely a should not be equal to 0. If a is 0, then it will no more be a quadratic equation, it will be a linear equation, right? So therefore the condition on a quadratic equation is the coefficient of x square should not be equal to 0, okay. And then the two roots of the quadratic equation are given by this formula, minus b plus minus square root of b square minus 4ac over 2a, right? You all know about it. Either by this formula, or if you can factorize, the quadratic equation, get the two values of x. The discriminant of the quadratic function, okay. Discriminant means it will decide whether how are your roots, how are your values of x, whether they are positive, whether they are equal, whether they are unequal and real, or whether they are non-real, means imaginary, okay. So delta will be b square minus 4ac, because it is in the square root. So when square root is positive, there is a possibility of two real and unequal roots. If the square root, the inside of the square root is 0, then the two roots will be equal, because plus minus part will become 0 and the two roots will be equal. and if the square root, the inside of the square root means the discriminant is negative, then it will no more be real root, because square root of a negative number is an imaginary number. You all know about it. So like that will decide. So when delta is greater than 0, then there will be positive real numbers, okay. So which will be a positive real numbers, and you will get two distinct real roots, one with positive sign, one with negative sign, between minus b and square root of delta. Then when delta is equal to 0, x is equal to minus b by a. This will be the only solution. So we call them repeated roots, okay. Yeah, we call them repeated roots because both the parts of the curve will touch the x-axis actually, okay. And when delta is less than 0 means negative, so it will not be a real number, and therefore there will be no real roots, right. So if a, b, c are rational and delta is a square, then the equation has two rational roots which can be found by factorization. I mean, if the square root is like 4, square root of 1, square root of 9, square root of 16, square root of 25 and so on, your two roots will be rational, right. It will not be irrational. Your two roots will be rational and unequal, means two different roots. Now sum and product of the roots. So for this equation ax square plus bx plus c, if alpha and beta are the roots, then the sum of the roots alpha plus beta will be negative b by a, and the product of the roots will be c by a. A is the coefficient of x square, b is the coefficient of x, and c is the constant term, okay. So sum of the roots will be negative b by a, product of the roots will be positive c by a, right. It has a use, this is very useful property of a quadratic equation or any polynomial equation, higher power equation. There also we are going to use sum of the roots, product of the roots, okay. Okay, then now the same thing is explained here. If your delta is positive, then the graph will be something like this. Why? Because it will meet the x-axis in 2 points, okay. It will intersect the x-axis in 2 different points, so that we will get two roots. One will be negative, the other will be positive, or maybe both of them are negative and both of them are positive. It depends on how is your curve. If your curve is like this, both the roots are negative. If your curve is like this, both the roots are positive, okay. So the two values of the roots will be on the x-axis, and this line, the vertical line, okay, this vertical line is called axis of symmetry. Let me write there, axis of symmetry. Yeah, this is axis of symmetry. X is equal to minus b by a, that becomes axis of symmetry, okay. The curve will be symmetrical about that line, right, okay. Again, for quadratic function y is equal to ax square plus bx plus c, we consider the discriminant delta is equal to b square minus 4ac, right. If delta is greater than 0, the graph cuts the x-axis twice. If delta is equal to 0, the graph touches the x-axis, okay. And if delta is less than 0, graph does not cut the x-axis. So I'll show you these three situations. When delta is greater than 0, your graph is something like this, okay. So it will meet in 2 points. When delta is equal to 0, your graph will touch the x-axis, so maybe like this, okay. It will touch the x-axis, or also it may touch from the lower side. Similarly, here also the graph may be upside down, the concavity may be downwards, okay. But still there will be two roots here, one here, okay. Then when delta is less than 0, then your graph will be something like this: x-axis, origin, y-axis, maybe above the x-axis, okay, or maybe below the x-axis, right? So because it will not touch the x-axis, right? Okay, now exponential function. You all know that the exponential function is e raised to x or a raised to x. A can be any positive real number, okay, which is not equal to 1 definitely, because if it is equal to 1 it will no more be an exponential function. Y is equal to 1 raised to x will be 1 only, okay. So it should not be 1, it may be between 0 and 1, or it may be greater than 1, right? So if it is greater than 0 and greater than a is greater than 0 and a is not equal to 1, then your graph is like this, okay. So this graph is also called as growth graph, right? Growth graph. And if there is nothing with the exponential function, then definitely it is going to intersect the y-axis at 1. So y-intercept will be 0, 1. But if there is something like this, y is equal to a raised to x plus 3, something like that, then of course it will meet at 4. I mean it will have the y-intercept 4, because this will be 1, this will be 3 when x is 0. So therefore your y value will be 4, so that will be your y-intercept, and your graph is something like this. That time your horizontal asymptote will be different, okay. Here the horizontal asymptote is the x-axis, y is equal to 0. Why? Because y is equal to a raised to x will never be equal to 0, right? So y will never be equal to 0. It means, it implies y is equal to 0 is your horizontal asymptote, right? Yeah, so remember this property. Okay. Now there are 4 cases for an exponential function. If your exponential function is something like this, y is equal to, let me write it here, y is equal to p into a raised to x minus h plus k, okay, something like this. Then when p is greater than 0, this p is greater than 0, okay, p is greater than 0 and a is greater than 1, then the graph is something like this, going up from left to right, but going up. Then when p is greater than 0, the coefficient is greater than 0, and the base a, exponential base a is between 0 and 1, then it will be a decay graph, okay. It will represent the decay of the function. So it will go down, right, from left to right but going down. This is also from left to right but going up. So this is growth graph and that one is decay graph. Now if the coefficient, your coefficient, it becomes negative, right? If the coefficient is negative, then because your y value will be negative. So when y becomes negative, when the sign of the y changes, the graph is reflected in the x-axis. You all know about it, right? So therefore in that case your graph will be reflected in the x-axis. So let me draw that graph. So the graph will be something like this, okay. It will be reflected in the x-axis when p is less than 0. When p is greater than 0, your graph will be like this, right? P greater than 0, okay. Now when p is less than 0 and a is between 0 and 1, then your graph will be something like this, okay, right. Your graph will be something like this. P is negative, and A is between 0 and 1. Similarly, when your P is greater than 0, P greater than 0 and A is between 0 and 1, the graph is something like this, okay, right? It will not go up, of course, it will be like this, going down but never meets the x-axis. This is the x-axis, origin, y-axis, right? So these are the 4 graphs. So I hope you will remember it. So the basically when A is greater than 1, you get a growth graph. When the coefficient of exponential function is positive and the base of exponential function means A is greater than 1, then you get a growth graph which goes like this, okay. And when A is between 0 and 1, then you get decay graph like this, right? Okay. And then when the coefficient changes from positive to negative, both the graphs will be reflected in the x-axis because your y value will change by a minus sign, right? Okay. The same thing is mentioned here, growth and decay graph. So anyway, I will draw again because maybe you didn't get it in the, okay, this is x-axis, this is y-axis. So growth graph is something like this, going up, okay, not even like this, it will be going up, okay, and here infinite, this point will be 0 and 1 for the basic value, right? This is called a growth graph. So in application of exponential function, you may get a question like bacteria is increasing or population of insect is increasing. So that graph will be like this. And then when you have A between 0 and 1, okay, x-axis, y-axis, then your graph will be something like this, okay. It will intersect again at 0 and 1, but it is going down. This is called decay graph, right? So this is decay graph. The first one is growth graph, right? Okay. Now natural logarithms. Natural logarithm means ln, okay. So ln of e raised to x is x because ln and e both are inverse of each other. So it is something like f inverse of f of x. Both will get eradicated and you get only x. So in the same way, ln of e raised to x becomes x, or e raised to ln of x becomes x, e raised to ln of x. So means one of them is f inverse of f of x equal to x, and f of f inverse of x is equal to x. These are the two examples for these two, right? Okay. Now laws of natural logarithm, I hope you already know it. Ln of m plus ln of m changes to ln of m multiply n. So plus changes to multiply when you combine the logarithmic function, natural logarithm. Similarly, ln of m minus ln of m n will become ln of m divided by n. So minus changes to divide when you combine, minus changes to divide, okay, when you combine the two logarithmic functions. Similarly, m into ln of b, any multiple, any scalar multiple to the left of ln will go in the power. So ln of b to the power m, that goes in the power, okay. These are the three rules. Then there is a rule for change of base. So if you have log of b to the base a, then you can write log of a up, log of b down, and you can have the same base. So I can give you example of this. So for example, if you have log of x to the base y, then you can write log of x to the base e over log of y to the base e, and which will in turn become ln of x over ln of y. So this is the use of it. Or maybe if you have log of 100 to the base 20, then you can write it as log of 100 to the base 10 over log of 20 to the base 10. And now you can check it in the calculator. So this will be 2 divided by this can be anything, 20. So you can write 2 parts of it, 2 times 10. So log of 2 to the base 10 plus log of 10 to the base 10, which will be 1. Because you all know that log of a to the base a is 1. Okay. Log of b to the base b is 1. Right. Similarly, log of e to the base e is also 1. Right. Okay. Now logarithmic function graphs are explained here. Now again the same thing we see here. If your exponential function is between 0 and 1, it will be a decay graph. It will go like this, right? And then if your a is greater than 1, then this will be a growth graph. It will go up like this. Now we can show the inverse function of this. The inverse function of the exponential is logarithmic function. So a raised to x will change to log of x to the base a. Okay. Because when you remove base from here, it will go and become the base of the log. Y is equal to a raised to x. When you take the base from this side to this side, it will become the base of log of y to the base a, and this will be x. Okay. So it is, as we have seen in the previous lesson, that the inverse function is the reflection of a given function in the line y is equal to x. So the mirror line is y is equal to x always for any type of inverse function, right? So red graph is for the inverse function log of x to the base a. The dotted one is the graph of this function, okay, decay function y is equal to a raised to x. So the whole thing is reflected in the line y is equal to x. So see, this part will be reflected here, then similarly this part will be reflected here, right? So you get like that. In the same way, the growth graph can also be reflected in the mirror line y is equal to x, and it will become the inverse function. The whole of the growth graph was above the line y is equal to x, therefore it will not intersect like this. It will have a separate graph which will be reflected in the line y is equal to x. Here for the growth graph for the exponential function, the asymptote was y is equal to 0, but for the logarithmic function the asymptote will be x is equal to 0, because whenever we invert a function, x becomes y and y becomes x, they get flipped. Okay. Now the properties of the logarithmic function, the domain of a raised to x is always x belongs to R. Any value you can substitute in place of x, no problem. But when you have a logarithmic function, the inverse of this function, then your x means whichever value you take inside log, that should always be greater than 0. We can never have a negative value. Why we cannot have a negative value? Because a raised to x is never negative, it is always greater than 0. Okay. So therefore your x here should always be greater than 0, right? Similarly, the range of the exponential function is y greater than 0, because it will never be negative, it will never be 0. Then for the exponential function, the range becomes y belongs to R, all real numbers, right? Then for the exponential function, horizontal line y is equal to 0 will be your asymptote. For the logarithmic function, the vertical line x is equal to 0 will be your asymptote. Okay. Okay, translations. Now we are studying transformations actually. Transformations. Okay. So under transformation of the function, right? So these are the transformations. Okay. Under that, we are going to study first the translation, right? Under transformation, the first thing is translation. Translation means shifting towards right or left, or shifting upwards or downwards, okay, along a straight line, of course. Along, I mean parallel to the x-axis, you will shift to the left or right, or parallel to the y-axis, you will shift up and down. It depends on what you are changing. So look here, y is equal to x minus h bracket square plus k. Your original function was y is equal to x square. Okay. Now you are changing it to y is equal to x minus h whole square plus k. So what are the changes here? You are subtracting h from x, so therefore it will get shifted to the right side. Okay. When you subtract from x, it will shift to the right. When you add into x, it will shift to the left. Remember this. X plus h will be to the left, x minus h will be to the right. But for the constant k which is added to the whole function, means we change in the value of y. When you add, it will go up. So when here k is added, look here, when k is added, the graph shifts up by k units. Okay. So k is the scale factor, or you can say k units, it will go up, right? So the same thing is described here for any function y is equal to f of x plus b. The effect of b is to translate the graph vertically through b units. Now when b is positive, it will go upwards. When b is negative, it will go downwards. Okay, graph will go downwards. Similarly, for a function, when you have y is equal to f of x minus a, when you subtract a constant from x, then when a is greater than 0, it will shift to the right. When a is less than 0, it will shift to the left. Why? Because minus of minus will become plus a. F of x plus a will shift to the left, right? And f of x minus a will shift to the right, okay, by a units. A units to the right, a units to the left, right? When you add, it will shift to the left. When you subtract, it will shift to the right, parallel to the x-axis, of course, right? And the translated translation can be described by a column vector a b, where a is the translation in x component, b is the translation in y value, I mean the x value and the y value. Okay. Okay. Now second thing in transformation is stretch. Stretch means the graph may get pulled up, or maybe graph will get compressed, right? So here the original graph was y is equal to x square. Now it has become y is equal to 4 times x square. So we are multiplying by 4 to the y value, because the whole value was the y value. So when you multiply y by a scalar 4, the graph will get stretched by scale factor 4 parallel to the y-axis. So it will go up. Okay. And that is why the original graph was here, but every point after the vertex is getting pulled up, right, on the left as well as on the right, and therefore the graph looks narrow, right? So this is getting stretched up by a units, 4 units here in this case, stretched by 4 units. Okay, by means the scale factor is 4, so 4 times it is stretched up. Okay, so whenever you have, there will be two types of stretch and shrink, or maybe you can call it dilation also. Stretch and shrink can also be called as dilation, right? So when your graph is y is equal to p into f of x, where p is greater than 0, then there is a vertical stretch of scale factor p invariant x-axis, means x-axis will remain as it is, it will not change, any x value will never change, only the y values will change. So y values will change and they will all be multiplied by p, because the scale factor is p. So each point becomes p times its previous distance from the x-axis. If p is greater than 1, the point moves further away from the x-axis. When p is between 0 and 1, points come closer to the x-axis. It means if you have a fraction here, instead of a number 4, if you have 1 over 4, then the graph comes down towards the x-axis. If it is a scalar number without fraction, then the graph goes up, okay, gets stretched up, right? So that is the meaning of p greater than 1, it will go up, p between 0 and 1, it will come towards the x-axis, means get shrink. Similarly, for horizontal stretch, if you have f of qx, where q is greater than 0, then the graph is stretched parallel to x-axis by a scale factor 1 upon q. So invariant y-axis, means any y value will remain same, the x value will be multiplied by 1 over q, right? If q is greater than 0, the graph will come closer to the y-axis, means it will get shrink, and when q is between 0 and 1, the graph will get pulled away from y-axis. So for x, everything is opposite. See, we have seen in translation, when you add any positive number into x, it will be, the graph will be shifted to the left. When you subtract any positive number from x, okay, in the function, it will get shifted to the right. So when you subtract, it will get shifted to the right. When you add, it will get shifted to the left. In the same way, for stretch also, when you multiply x by a number greater than 1, then it will get shrink, it will come towards the y-axis, the graph will come towards the y-axis. But if you multiply by a fractional number between 0 and 1, then the graph will get pulled out, okay, by the reciprocal of that multiple, means by q. If it is 1 over q, then it will be pulled out by q, and if it is q, then it will be shrink, it will be get shrunk by 1 over q, right? So I will show you examples of all these. See, suppose let me write it, y is equal to x square is your graph, then y is equal to x raised to 4 into x square you have seen here, okay. Now for y I will show, for x I will show you y is equal to x square. Now suppose you change it to y is equal to bracket half x square. Now we are multiplying x by a fraction. So when you multiply x by a fraction, graph will get pulled away from y-axis, right? So look here, your original graph is 1 minute. Let me move it here. Your original graph was like this, okay. Now when you multiply it by half, so your graph now will go away from y-axis. Every x coordinate will get multiplied by 2. So suppose if your point here was 1 and 1, then by half means it will become 1, 2 and 1. Suppose if your point here was 2 and 4, then it will become 4 and 4. So y coordinate remains invariant, it will not change, right, for the stretch away from the x-axis, from the y-axis. Okay, when you multiply any x by a fraction which is between 0 and 1, then the graph will get stretched. If you multiply it by a integer number which is greater than 1, then it will get shrunk. Okay, so suppose if your graph is from y is equal to x square, if it changes to y is equal to 3x bracket square, now the graph will get shrunk. Okay, this is your x-axis, origin y-axis. So your original graph is suppose like this. Okay, now when you multiply it by 3, the graph will come closer to the y-axis. See, so any point on this graph, suppose original graph, if it was 2 comma 4, then it will become 2 by 3 comma 4. It will get divided by 3, right, because it will come towards the x-axis. 2 by 3 times 4. So I hope you understood this part. Then there is reflection. The third thing in transformation is reflection. It is very simple thing. When the sign of y changes, the graph gets reflected in the x-axis. When the sign of x changes, the graph gets reflected in the y-axis, right? So look at this. Here we are multiplying whole of the function f of x by minus sign. So sign of y is changing, therefore this graph which was here will get reflected in the x-axis. So the same graph which was up will come down. Okay, exactly, it will be reflected in the x-axis. In the same way, when you change the sign of x, so f of x was this function, the dotted one was the original function. Now everything will get reflected in the y-axis. So this point will get reflected there, this point will get reflected there, and accordingly the whole graph will be like this. Okay, these points go there, these points go there, like this, like this, like this. Okay, yeah, okay then. Now let us solve some past paper question, because there was nothing very important. Anyway, I am going to solve past paper questions, the full past paper questions towards the end of this lessons. Okay, so look here. Now this question says f of x is a into x minus h bracket square plus k. The vertex of the graph of f is 3 comma 4. The vertex is 3 comma 4 and the graph passes through q 1 comma minus 4. Write down the values of h and k. Now look here. Since the vertex is 3 comma 4, now look here, in this function this h and k is nothing but the coordinates of the vertex. Okay, so therefore h will be 3 and k will be 4. Now also remember, if it is minus x minus h, then your x coordinate of the vertex will be positive h. If it is x plus h, then your x coordinate of the vertex will be negative h, right? So this is the vertex. Now let us see the b part, what it says. Find the value of a. Now we have h, we have k, so we will put back both the values. So f of x will become a bracket x minus 3 bracket square plus k means 4. Now as it passes through the second point, 1 comma minus 4, the q point. So we'll put it replace x and y by 1 and minus 4. So we plug in minus 4 in place of f of x, so minus 4, and we plug in 1 in place of x, so 1 minus 3 bracket is square plus 4. Okay, negative 4 will come there, positive 4 will come here and become negative 4. So negative 4 and 4, 8 is equal to a into 1 minus 3 minus 2 square is 4. So we divide by that 4. So therefore a will be negative 2. Okay, this is the value of a. So it is simple. You can easily find the unknowns if the coordinates are given through which the graph passes, right? Okay. Now next question. Next question says f of x is 3t square plus 27 where t is greater than 0. The graph of the function g is obtained when the graph of f is transformed. What are the transformations? The first one is a stretch by scale factor 1 over 9 parallel to the y-axis, right? It is getting transformed parallel to the y-axis by scale factor 1 over 9, and a translation by vector 4 and minus 5. So 4 is in the x values and minus 5 is change in the y values, right? Okay. So by these two transformations, your function will become a g of t, not f, no more it will be f, it will become g of t, and to g of t we are going to write 1 over 9 f of t minus 4. Okay, and because this translation is by 4 towards the right and this translation is negative 5 towards downwards, so minus 5 will be here. Is that clear to you? See, first is stretched by scale factor 1 over 9, so we multiply by 1 over 9 to f, and then there is a transformation by vector 4 and minus 5. So 4 is to the right side, therefore t minus 4 we will write, and 5 is downwards, therefore we will write minus 5. But because also there is a square, so I will keep the square, right? So this is the transformation we want. Now f will be replaced by these values. So let us see what it will become. 1 by 9 f. F means what? Now everywhere in f you replace t by t minus 4 and then minus 5 will be outside it. Okay. So the whole f function will change by t minus 4. Okay, and we will write everything, the constant will remain as it is. So 3 into t minus 4 bracket is square plus 27. Look here, I have changed t by t minus 4 and t square remains, bracket is square. Okay, so this is the change. I hope you understood this. Now when we open the bracket, 3 multiplied by 1 by 9 will give me 1 by 3 t minus 4 bracket is square, then 27 by 9 will be, see this 27 divided by 9 will be 3, and 3 minus 5 will give you minus 2. So the whole function will become this. So g of t is this. Let me highlight it. Okay. Now the second part says a particle moves along a straight line so that its velocity in meters per second at time t seconds is given by g of t. Okay, I mean this becomes the velocity. G of t is the velocity. So this is the velocity of the particle, right? This is the velocity of the particle. Find the distance the particle travels between t is equal to 7 and t is equal to 10. Now look here, this is velocity. So when you integrate, it becomes displacement, but when you take the modulus of that integral, then it will become the distance moved. Okay. So what we will do for b part, I will write it here. B part, distance travelled will be equal to integral from where to where? From 7 to 10. I mean the time is between 7 to 10 seconds. So 7 to 10. And now I will put the modulus for the whole g function, right? So g function is 1 by 3 t minus 4 bracket is square and minus 2. Everything will be inside the modulus so that we get distance moved or distance traveled. Now this you can find by integration, okay, by calculator, because this is a calculator question. So I will go to math, then integral, and I will use modulus, right? So my modulus function is 1 minute, math, absolute value. So 1 by 3 and then bracket x minus 4, because I cannot use t, x minus 4 bracket is square minus 2 from 7 to 10. So my answer is 1 minute. I will show you on the screen, right? So this is 15 meters, because it is meters per second. So answer is 15 meters. Actually, while calculating on the calculator, you have to be very careful. I took 1 over 3 directly. I should not do like that. I should write in the bracket 1 over 3. So the whole thing became 1 divided by 3 times the whole function. So everything will change. So you have to be very careful. Put it like that in the calculator and then your answer will be correct. Okay. So this is the question. End of this question. Now question number 3. This is the last question, because I am choosing few questions, as I am going to cover most of the past paper questions towards the end of this syllabus. Okay, let us see the question. The function f is defined by f of x is equal to 1 plus 4x over x plus 3, where x is not equal to negative 3, because it is in the denominator, so it should not be 0. Sketch the graph of y is equal to f of x, indicating clearly any asymptotes and the points of intersection with the x and the y axis. Now look here, first thing is the function should not be like this. Whenever there is same degree of the numerator and the denominator, or more power in the numerator than the denominator, then we have to divide and simplify first. So what I will do for a part, before I sketch, 4x divided by x plus 3. So I will multiply by 4 in the quotient. So 4x plus 12. When I change the sign, this will get cancelled. Negative 12 is remaining. So 4 is the quotient. So 1 here and 4 here will become 5. So the actual function will be f of x is equal to 5, and minus 12 has to be divided by x plus 3. Now it is very clear, because the integer part is separated from the fractional part. Now I can plot the graph of this. So I will draw the x axis and the y axis. Okay. Yeah. X axis, origin, y axis. Now look here. If you look at this function, so you should always remember that any integer part is the horizontal asymptote, and from the denominator we take x is equal to negative 3 as the vertical asymptote. So here y is equal to 5 is horizontal asymptote. I will shift it up so that I can occupy the remaining part. Yeah, and x is equal to minus 3 is vertical asymptote. So I will draw the vertical and the horizontal asymptotes first. Y is equal to 5 is somewhere here. and x is equal to negative 3 is somewhere here. Let me pull it up further, and then this is x is equal to minus 3, horizontal asymptote. Now because the x is negative, look here, negative of x, so therefore your graph will be in the second and the fourth quadrant, I mean in that sense. So therefore when I draw the graph will be something like this here and something like this here. It should be between the two asymptotes, right? Now the question also said find the any point which are on the x-axis and the y-axis. So what we will do, we will put x0, so that will give us the y coordinate. So when you replace here, see x0, it will be 5 minus 12 over 3. So 5 minus 12 divided by 3 gives me 5 minus 12 divided by 3. Okay, so I am going to get the points when x is 0, it is my y coordinate. So therefore this will be 0 comma 1, right, when x is 0. And then when I put y0, so 5 minus 12 by x, look here, I will write it here, 5 minus 12 by x minus 3 is equal to 0. That will give me 5 is equal to 12 over x plus 3. Then this goes there, 5 comes here, so x plus 3 will be 12 over 5, okay, 12 over 5, and then this 3 will come here, negative 3. So 2.4 minus 3, so your x will be 2.4 minus 3. 2.4 minus 3 will give me negative 0.6, comma 0. So these are the x and the points on the x and the y axis, and the asymptotes are x is equal to minus 3 and y is equal to 5. So first part is over. Now second part says find an expression for f inverse of x. Okay. Now look here. To find the inverse function, let me write first the given function y is equal to, what was it, 1 plus, but we wrote 5 minus 12 over x plus 3. 5 minus 12 over x plus 3. This is the given function. We know that okay, f inverse of x is x, right? Okay, so therefore it will be f of y, which will be equal to x, right? Now we replace every x coordinate by y, every x term by y in the given function. So therefore 5 minus 12 over y plus 3 will be equal to x. This x remains x. Now we will simplify and make y the subject. So 5 minus x will be 12 over y plus 3. Now take this there, bring whole of it here. So y plus 3 is 12 over 5 minus x. So y will be 12 over 5 minus x minus 3. This is the value of y. Therefore I will write it here, f inverse of x will be 12 over 5 minus x minus 3. If I take the LCM, 5 minus 3, 5 minus x, so 12 minus 3 into 5 minus x. Now after simplifying it, 3 times 5, 15, and minus plus 3, so 3x minus 15 plus 12 will be minus 3. So 3x minus 3 over 5 minus x. So that will be our final answer for f inverse of x. Okay. Yeah, I will erase the extra part. So this is the answer for the f inverse of x, right? I hope you understood this. Then C part says, I will copy it there. Find all values of x for which f of x is equal to f inverse of x. Okay. Now look here, f of x is equal to f inverse of x. F of x was 5 minus 12 over x plus 3. F inverse x was 3x minus 3 over 5 minus x, right? I will take the LCM on the left hand side also and combine both the terms. So x plus 3 multiplied by 5 will give you 5x plus 15 minus 12. So this will be 5x plus 3. X plus 3 is equal to 3x minus 3 over 5 minus x. Now cross multiply them. So therefore 5x plus 3 into 5 minus x is equal to x plus 3 into 3x minus 3. So multiply and open the bracket. 5 times 5, 25x minus 5 x square plus 3 by 3, I will open it. 3 5s are 15 minus 3x is equal to, now by x I will multiply, so 3x square minus 3x, and then by 3 I will multiply, so plus 9x minus 9. Okay. Minus 3x and plus minus 3x on both sides I will cancel. Then this 5x square I will take there, so it will be 3 and 5, 8x square. 25 also I will take there, so 9 minus 25 will be minus 16x, and 15 also I will take there. Minus 9 minus 15 will be minus 24, and here it will be 0. Dividing by 8 I am going to get, I will write it here in this space. Okay, dividing by 8 I will get x square minus 2x minus 3 is equal to 0. So x minus 1, x plus 1, x minus 3, that will be my factors. So therefore x is equal to negative 1 and 3, both are the values of x. Like this we have solved f of x is equal to my f inverse of x, right? Now D part of it. D part of it says, solve the inequality modulus of f of x is less than 2. Modulus of f of x is less than 2. Let me copy it here. Modulus of f of x is less than 2. So we will write the given function in the modulus. Okay. So modulus, also what we can do, we can remove the modulus also. So when you remove the modulus, there will be plus minus sign. So this implies, see, plus minus f of x less than 2, and that gets converted to negative 2 less than f of x less than 2. This becomes now easy. So f of x, now when we take the inverse of each part, so f inverse of negative 2 less than f inverse of f of x less than f inverse of 2. So here f inverse and f will go, we are left with x only, less than f inverse of 2. Now here one time I will replace negative 2, another time 2. So f inverse of negative 2 will be 3 into negative 2 minus 3 over 5 minus of minus 2. So negative 6 and 3 negative 9 over positive 7. Okay, negative 9 over 7 is one value, and f inverse of 2 will be 3 into 2 minus 3 over 5 minus 2. 3 to the 6 minus 3, 3. 5 minus 2, 3, so it is 1. Okay, so therefore negative 9 by 7 is less than x is less than 1. This is the answer, right? So this is the easier way to solve that inequality. Modulus of x, modulus of f of x less than 2. We convert it to f inverse so that in the middle we get x, right? Now the last part, let me copy from here. Now look here, here it is given as f of modulus of x, be careful about it, right, less than 2, right. So let us write the same function f. F was 5 minus 12 over or let me write the original function. Let me copy it from here. I will copy the original function f of x from here, put it there, and then put the modulus, right. This is the given function. Now everywhere I am going to put modulus wherever there is x, like this, okay. So therefore 1 plus 4 into modulus of x divided by modulus of x plus 3 less than 2, right. Now I'll move 1 there, okay. So 2 minus 1, 1. So 4 into modulus of x over modulus of x plus 3 is less than 1. Now this goes there. So 4 into modulus of x is less than modulus of x plus 3, okay. Now bring the modulus here towards the modulus. So 4 minus 1 will be 3 modulus of x less than 3. Divide by 3, so modulus of x is less than 1. So therefore minus 1 is less than x is less than 1. This is the solution, right. So x is between, we can write it as an interval between negative 1 and 1, right. So this is the solution of the last part. Either this way or this way you can write, okay. So this is the end of this lesson. This was a combined lesson, okay. So we have completed 9 lessons. This was 7, 8 and 9. Now next lesson will be 10th lesson, which will be on topic 3, geometry and trigonometry. So distance between 2 points in 3 dimensions, then the volume and the surface area, okay, cone and sphere, hemisphere, and combination of these things will be there. Then sine and cosine rules, okay, sine rule is this, cosine rule is this. So we are going to study that as a 10th lesson, so that we can finish it faster before the end of this month of October, okay. So I hope you liked my lesson, okay. So if you have liked my lesson, please like, share and subscribe my YouTube channel so that I get encouraged. If you have any doubts, you can contact me on my email ID, or you can contact me on my WhatsApp, okay. Link of this PDF is there in the description of this video, right. Okay, then bye.